Welcome, and today we're going to be looking at building a DCC decoder circuit to work with either an Arduino or an ESP32 or, to be honest, many other microcontroller boards, but I'm just going to do the examples for these two boards at the moment. So let's have a look at what we're going to build and why. So here we have a couple of conventional DCC decoders, accessory decoders. We've got the Digital Plus LC150 from Lens, and I've got an NCE Snap-it controller. Now this will give the Digital Plus one by Lens will give you 6 outputs for sort of solenoid point motors, and just checking on eBay, they're over £50 a piece. These things for a single output, they're £20 a piece in the UK. Expensive stuff. So let's have a look at what we can do with an Arduino. So here we have some Arduino shields. I've got this one here that is able to control 4 servos. This one here, this is actually a stepper motor driver, and again I've got outputs for 2 servos. Obviously I could put a lot more items on these boards if I wanted. This one was actually used for controlling a turntable and 2 points, whereas obviously this is just controlling some points. It also used to control various lighting effects, and obviously these shields just plug onto the top of an Arduino Uno. Now this one here, this is one that I've sort of built on a separate circuit board. Again, you could build it with the ESP32 mounted on the same bit of Vero board, which is what I usually do. This one's been kept separate because I keep it for testing. But what we just need to do is to build this circuit, and this circuit takes the signal from the DCC controller and presents it to the Arduino or the Uno in a format that it can read, and we can then do stuff with it. Now obviously we've got to build these ourselves, and there's still a cost involved. So for the components, and I'll show you what they are in a bit, it works out at about £6 to build 5 boards. The components are so cheap that the smallest quantities are for 5. The ESP32 I get for about £6. So even if I was just to build that one unit and throw 4 sets of components away, that's going to cost me £12. With that, I could control probably 30 accessories. If I add a shift register, goodness knows how many, and if I add some PCA 9685 boards, endless servos. If you're building it on an Uno and you're going to use a prototype shield, then you're going to pay a bit more. It's going to cost about £20, but again you could have almost limitless numbers of items controlled. So these work out very, very economic. So let's have a look at how this is all done. As usual, I've done a reference page for this project on the Digital Town website. There'll be a link below the video. The items you need are a 6N137 opto-isolator, a pair of 10K resistors, a 1K resistor, and a 1N4148 diode. Now I'm going to be honest, these particular items are so cheap that there's no difference between buying one and buying 100. So I just buy them in packs of 100 or 50 if they're a few pennies cheaper. I've got bag loads of them. The opto isolators, I think the first link I went on, it was 5 for £1.30. So again, very, very cheap items. Now going down to the circuit, and what I'm going to do, although I've done the circuit diagram, I'm going to actually do a walkthrough of how the circuit is built. The circuit is fairly simple. I've done 2 different versions, one for the ESP32, the other for the Arduino. You'll notice there is a red dot on the opto isolator, and I'll show you why that is in a bit. That shows you where there's a particular dimple in the component, and it shows you which way round to put the item. Now if you're wondering what the opto isolator does, DCC usually is going to input 12 to 16 volts depending, what setup, what gauge you're on. And our Arduino likes 5 volts as a maximum, and the ESP32 will blow up at above 3.3 volts. So sticking sort of 12 volts into an ESP32 is going to get very smoky, and the same for the Arduino. So what the opto isolator does is inside it has a circuit that keeps the high voltage circuitry completely separate from the low voltage circuitry. It actually passes the signals across using light, so there is no sort of physical connection for the circuit, so the DCC power cannot get to the ESP32. That's going to save us a lot of pain going forwards. Right, let's see how to build this thing. So we start with our opto isolator, and that red dot is to do with this small dimple on the 6N137. Just to help you sort of make sure you get this thing the right way round. And we start off, I've used one of these tiny little breadboards for this project. Once again, you can see the dimple here, and the first thing that you do is you put in the diode from this sort of second pin and sort of clear the edge of the unit, because we're going to have to plug something else in here. So that's your diode. Obviously make sure that you get the correct the diode in the correct order. If you put it the other way around, the circuit won't work. Now, once we've got the diode in place, we put in our first resistor. This is the 1K resistor. Notice that the end of the resistor is on the same pin as the end of the diode. So just place those items in. The next thing we do is put a jumper from the counting along the third pin, and this goes into the same line as the other end of the diode. So this is just a sort of a bridge across that is required. The next item then, add your first 10K resistor. This goes from the second pin on the Arduino side, if you like, of the opto isolator. And then put a second resistor in. So the two resistors end at the same point, but obviously are connecting to these two different pins. The next item we then put in is another jumper. This comes from the first pin and again plugs into the same line of the breadboard as the ends of those two resistors. And once that's done, basically the circuit is complete. Now all I've done is I've plugged in two green wires. One goes on to the end of that 1K resistor, the other goes to the end of the diode and this blue jumper. And those two items go off, and this goes to my NCE power cab. So these two green wires have got the DCC signal coming into my board. When we look at the other side, the first thing you need to do is on this pin is I've put a black jumper in, and this one goes to the Arduino ground. Moving forward, I then plug a yellow jumper into the next pin, and this is going to pin 2 on the Arduino Uno, and on my ESP32 I tend to plug it into pin 4. Now you cannot mess around too much with the pins on the Arduino, because the Arduino Uno only has 2 interrupt pins. That's pin 2 and pin 3, and this yellow wire must plug in to an interrupt pin to work correctly. The ESP32, you've got far more options on which pins to plug it into, but I plug it into pin 4 just because I always plug it into pin 4. It's as simple as that. Now the final wire is the red wire. This jumper is connecting to that orange and the end of the 2 resistors, and this one goes to the 5 volts on the Arduino Uno, or if you're using an ESP32 then you would plug it into the 3.3 volts. And finally you're going to finish up with a circuit that looks like this. Your DCC connections coming in, and then your outputs to your Uno or your ESP32. Now, going back to our circuit diagram, just to give you a little bit of a heads up as to the mistakes that most people make. I've helped a few people build these, and the common mistake is they tend to miss out either this jumper, or they misalign the ends of these resistors and that jumper. So just a little heads up for you there, and obviously make sure you get the opto isolator the right way round. But those tend to be the biggest issues that people come up with. So once we've built our circuit, we now need to load some software, and I have installed the example from the NMRA DCC library, and I'm going to use NMRA DCC Accessory Decoder 1, which is this particular sketch. Now, I'll be honest, I've already uploaded this to the Arduino Uno. Notice I'm using this for the Uno. I have had some issues when using this with the ESP32. I'm told you can get it to work, but I've actually got a separate sketch that I use for that I'll show you in a minute. So this is for the Uno. Let's just click on the serial monitor and let's get this thing running. So here we have our circuit and my power cab. I'm going to select an accessory. I'm going to use number 73, and when I click a direction, we can see that we get an output. Now you might notice that we get the output a number of times. We'll try another sort of address just to get the idea. There we go. That's the output. Simple as that. Now you might start to wonder why we are getting those multiple addresses. The reason for these multiple addresses is actually to do with the NMRA DCC specifications. So when a address is sent out, if you like, when a signal is sent out, when it's sent out to a loco, when it's sent out to a decoder, the signal is sent out more than once. This is because if your engine is running along and it's over a dodgy bit of track, it might not receive the command. So the system sends it out 4, sometimes 5 times. It varies from one DCC manufacturer to another, but it just sends it out a number of times. Now, the way this works in this sketch is as follows. So in this particular sketch, there is a function, notify DCC-EX turnout output, and you can see that is sent out to the serial monitor. Now there are a load of other functions, and you can basically delete the functions that you don't need, because in this instance we're only going to be using the DCC accessory turnout output. And then what you would do to get this to control whatever you want to control, what I tend to use is just put a switch statement in. Let's just move that down. So I would go switch, and then the address, and then I tend to put the default in first with a break. So anything that's not meant for this board, we ignore it. And then what we're going to do is we'll put in case, we'll call it 123, so address 123, and we'll put in if the direction is greater than 0. This is basically where you would put your code to drive a servo, turntable, whatever you want. We'll just put in serial print line 1. Sorry, a bit unimaginative there. What on earth's going on there? There we go. And we will put in the opposite on this side. mess those up a bit. Right, here we go. dir 0. So let's get that uploaded. So this time we're going to select the accessory, and I've already put in 1, 2, 3, and if we press A1, we see here that we get notified of our direction 1. If I press the 2, we see the opposite. It's as simple as that. So going back to our code, if you wanted to control a servo, solenoid, whatever you want to do, turntable, this is where you would put your code in. You'd have your address, your direction, and then decide what you want to do. That's how it works with the Uno. Slightly different with the ESP32. So for the ESP32, all you need to do is go on the Digital Town site. There is a link off this page to an ESP32 DCC accessory decoder. I did a whole project on how to build this particular item, so you can see here's the whole circuit soldered onto a Vero board, and obviously I then mount the ESP32 on board. I think this one on the right is controlling some servos. There is a sketch at the bottom of the screen, at the bottom of the page, and it is called, he says, looking for it, there we are, decoder functions, and there we are, ESP accessory decoder Inno. There's a couple of files, there's some instructions on how to install it. Once you've got those files installed, basically it's a very similar sketch to the NMRA one. The only thing that I did was I basically reduced it down to the single function that you need to use, and it uses sort of the board, the accessory address and the direction, and in a similar way you do a switch statement on the accessory address and an if statement on the direction to put your code in to do whatever you want to do. So the two projects work very similar. The reason that the NMRA sometimes has some issues is to do with the way that the ESP32 sets up its interrupts. You can go into the NMRA decoder and sort of mess around with it, but I just wrote this because it was easier, and if you just want a straightforward answer, just go to this particular page. Now, when I wrote this sketch some time ago, I was still using input pin 2, but obviously if you change that to a 4, it will work with the current circuit, or just change the input pin to 2. This sketch actually works on the Arduino Uno as well, so you could use it for everything. Anyway, let's look at some other bits to do with the circuit. So much as building it on a breadboard is absolutely fantastic, it's not going to stand up to any bumps and bangs. So as you saw on the desktop earlier, I tend to solder these onto some bits of Vero board. I've got this one just set up on its own. That's because I use it a lot for testing. But looking at these ones, you can see the circuit is embedded into this Arduino shield. These are my servo outputs. Now these were running NeoPixels. I forget what this was running. You see there's various outputs, and this is one of the joys of building your own DCC accessory decoder, because not only can you then get it to drive servos or solenoids or whatever, but you can have building lights. You can connect to sort of PCA 9685 boards, shift registers, all sorts of components. So you can now use your Arduino to do far more than any sort of commercial product would be able to do. As I said, this is a stepper motor with a couple of servos again. Again, you see the circuit sort of soldered in here. These sat under my layout for a long time. As you can see, all the different outputs, I put plugs on this one. It's up to you how you put these onto your boards, but I would recommend that you solder them onto something stable, because trying to just run the project on a breadboard it's never going to last very long. Now, I've also included a link to a DCC decoder example that's controlling servos and LEDs. This was another project that I did. I think this one's running on an Uno, but as you can see, we've got LEDs, servos, all sorts of things, because you can control so much from a single decoder board. It's just unbelievable just what you can do. So this is the joys of building your own decoder. Anyway, I hope that's been useful to you, and if it is, please click the like and subscribe. Don't forget, all of the circuitry, all of those images are all on the Digital Town website, so you can go through them at your own pace. So anyway, thanks for watching, and see you again in the next video. Bye for now.